Today's Tech Talk is on pressure vessel compliance. Most pressure vessels require inspections every 2 years to identify any issues. Key standards include AS 3788 for maintenance, AS 1210 for design, and AS 4343 for hazard levels. You can refer to these standards if you need to, but the purpose of today's session is to dig into some of the more common issues we come across, like incorrect pressure relief valve ratings, broken tamper seals, dial indicator errors, pressure relief pipework, and our mortal enemy, corrosion.
The majority of issues we come across on our refrigeration receivers are located at the manifold on top of the pressure vessels.
If you have a pressure relief valve that has a higher rating than the vessel design pressure, it is not protecting what it is designed to protect. This incorrect PRV needs to be replaced. Keep in mind, if you need to request a replacement PRV, please specifically mention that technicians must check and set the high-pressure safety switches on the compressors and the rack. This is crucial because if those switches allow the system pressure to exceed the new PRV release pressure, the system will vent refrigerant.
Remember, tamper seals must always be intact. If you find a seal that is broken or missing, it indicates the valve may have been tampered with or compromised, and it requires immediate attention. Pay close attention to the dial indicators. If the indicator is not zeroed, it may signal that the PRV has leaked or is leaking refrigerant. Since these indicators cannot be reset on site, a replacement PRV and indicator is required.
Another critical requirement is that all pressure relief valves must be vented to a safe area. Failing to do so poses a significant injury risk to technicians. If pressure is released while a technician is close to a relief valve, they could receive cold burns from liquid refrigerant or hearing damage from sudden pressure release. In the worst case, leaking refrigerant could displace oxygen in the room, creating a life-threatening breathing hazard. These hazards are easily managed by installing pipework from the PRV that allows pressure to release to a safe location, ideally outside.
Finally, address any rust or corrosion on the vessel. Untreated corrosion threatens integrity, reduces lifespan, and increases leak risks. The solution is to remove the corrosion, treat the metal, and repaint. If pipework insulation is damaged, repair or replace it to protect the vessel shell from future corrosion. Not all pressure vessels you might come across in our stores have registration certificates or require routine inspections. The requirement is based on the vessel's physical dimensions, capacity, and hazard level. The general rule of thumb for our refrigeration and air conditioning equipment is the receiver needs to have a nominal internal diameter of 230 millimeters or 100-liter capacity to require a PRV. These smaller vessels should have other protection mechanisms, such as a fusible plug fitted above the liquid refrigerant level, at least one joint incorporated in or adjacent to the vessel that is designed to fail at a temperature not exceeding 725 degrees Celsius. This is done using silver solder, which melts below this temperature. You might come across this style in older stores that still use individual systems for their refrigeration. You might also come across mass-produced pressure vessels on air conditioning equipment or small self-contained refrigeration units. These sequential serial number vessels are also exempt from inspection. Although the hazard levels are lower on some equipment, it is still important that you diligently check and maintain all equipment, particularly against corrosion.
We hope you enjoyed this Tech Talk and learned something. If you would like to know more about anything we discussed, or if you have any topics or ideas for future Tech Talks, please reach out.